Okay, so these are, we're going to skip the middle example. We're going to do the first and the third examples, and this will hopefully help you out here. But we have x squared plus y squared equals r squared. We have sine squared plus cosine squared equals 1. Okay, so those are the two pieces that we have. And it says sketch the curve represented by the parametric equation. Find a rectangular coordinate equation for the curve by eliminating the parameter. So do you see a relationship between these two expressions? Okay, so what we want to do, though, is we want to write it so that there's no longer an x and a y equals, but that the x and the y are together. And if we want to eliminate the parameter, that means we want t to go away. So we want to somehow figure that out. That's our goal. How do we get those t's to go away? Well, let's see what we can do here. Let's take out our calculator and graph it. If you just want to watch mine, that's fine. It's up to you. We have x is equal to 5 cosine of t. Whoop, I'm sorry, I'm in the wrong mode. I'm currently in polar mode, right? Because I was doing a problem from section 9.6. So let's move mode, go down to parametric. Parametric has the x and the y equals. So I go into y equals and I get, all right, so I've got 5 cosine of t, and we've got 3 sine of t. And I'm going to graph this in a normal viewing window. What shape do I get? Well, we don't know if it's a circle until we zoom as a square, number 5. So let's see what that gives us. It's an oval, but in mathematics we don't use the word oval, we use the word ellipse. This is an ellipse. And if you remember, an ellipse has an equation that looks like this. X squared over a squared plus y squared over b squared is equal to 1. So we want to make this parametric equation look like this. And we can do that. And I'm just going to show you a little trick. This sine squared plus cosine squared equals 1. That looks pretty useful, doesn't it? Because it very much resembles what the equation for the ellipse is going to look like. All I have to do is get rid of the sine and the cosine. So I'm going to square both sides. X squared equals 25 cosine squared of t. And y squared equals 9 sine squared of t. So now I have a cosine squared, don't I? If I divide by 25, I have x squared over 25 is equal to cosine squared. If I divide by 9, I get y squared over 9 is equal to sine squared of t. So now can I make that substitution? Yeah. Instead of sine squared, I can write what? Y squared over 9. Instead of cosine squared, I can write x squared over 25 is equal to 1. And you guys learned that an ellipse, this will be stretched 5 units horizontally, 3 units vertically, right? And if you look at our graph, that's exactly what the ellipse does. 5 units horizontally, 3 units vertically. There you go. So that's our final answer. Because it says eliminate the parameter. So t is gone. And rectangular coordinates. Well, rectangular coordinates are x and y coordinates. So I've done my job. Any question about that one? So you can do it? All right. We're going to skip this one. All right, example 5, you're going to have a problem just like this on your test, I promise. So some people find this a little bit confusing, but I think if you're patient, I think you'll do just fine. So it says, find parametric equations for the line with the given properties. We want a slope of 4, and we want to pass through negative 2, 5. Now, when you write an equation for a line with a slope of 4 and passing through negative 2, 5, can you write it in this form? Do you know how to do that? We should. Yep, this is algebra, 9th grade, 8th grade. So what I'm going to do is I'm going to plug in my slope, which is 4. I have to solve for b. How do I do that? Plug in x, plug in y. So y is 5. I have 4 times negative 2 plus b. 4 times negative 2 is negative 8. So I get 5 equals negative 8 plus b. 13 is b. So y equals 4x plus 13. So you know exactly what that looks like. It has a slope of 4. It has a y-intercept of 13. Well, great. But we want to write that in parametric form. Now, it's not because parametric form makes it easier. It's because we want to understand the process of how it happens. If we had more time, we would write other equations in parametric form, but we don't quite have that same amount of time. So here's what I'm going to do. I'm going to sketch the graph. Okay, and this is a line that has a slope of 4 and passes through negative 2, 5. I'm going to plot negative 2, 5. Can I generate another point on that graph? How? Up 4 over 1. So I go up 4 to 9, and I go over 1. Can I generate another point? Yep, up 4 over 1. Okay, so there we have it. Okay, those dots represent the graph, right? Now you learned earlier, if you flip to the other side of your notes, you remember that we made this type of equation, or this type of table. We had a t value along with an x and along with a y. Right? You did that on your homework? Well, slope of 4 passes through negative 2, 5. We don't really have any t values there, do we? We just have x and y, so we need to create t values. Okay? So I'm going to talk about t being each one of these points. So this is my starting point, and then I go over a certain amount and up a certain amount. So that green step would be t equals 1. So at time 1, we finally reached here. And then we moved again. That would be my second step. Then third step and fourth step and so on like that. So where are we at time 0? Negative 2, 5. So at time 0, I have an x value of -2. I have a y value of 5. So think of it as a motion. You know, this graph is plotting points. Every, say, second, it moves on up according to that slope. At time 1, what's my coordinate? Good, -1, 9. At time 2, what's my coordinate? 0, 13. Are you surprised that you got 0, 13? Oh, no, because we know that the y-intercept's 13. Okay, I'm just using this to check my answer. So what are the x's going up by each time? The x's are going up by 1 each time. So my next coordinates will be 1 and 2. What are the y values going up by each time? 4. So I have 17 and 21. So because the slope is equal to 4 over 1, which is y over x, you can see the change. You can see the change every time. Okay? Well, now we're just going to write a new equation. Okay? X, whoop. We'll write it over here. As you see in your parametric forms, you have to have an x equals, and you have to have a y equals, and you have to have a t. X equals, y equals. What is the increase in the t every time? 1. It goes up by 1. So let's just focus on the x's now. As x relates to t, okay, x goes up by how much every time? 1 over 1. So what's going to be the slope of the x equation? 1. Now, let's figure out what the y, or what the t-intercept is, I guess. If t is 0, what is the x value? -2. I know. I wish that there were more desks in this room. Then you guys would be able to like see every single time I walk up to the board. All right. So we have that. Now we have y equals, okay? And what is the increase in y every time? 4, and t increases by, so the slope is 4. For the y equation, the slope is 4. So I have 4t. When t is equal to 0, what's y? 5. So I'm going to take that and plot that to make sure that we come up with the line y equals 4x plus 13. What's the question? Those are the answers. We wrote it in parametric form. Let's graph that on the calculator to see if we actually come up with that line. I go into y equals, I type in t minus 2, and then I type in 4t plus 5. And when I go to my graph, what part does it draw? I'm going to go to the window. I'll increase the y maximum up to, we'll go up to 20, and we'll look at the graph again. Why doesn't it draw the bottom part? Because we've specified that t begins with 0, so it just draws from here on up. If we wanted to include negative time, so to speak, we would just go up to our t minimum, and you could create that to be, negative 20, whatever you want. And then it will draw the positive. Oh, it even draws the negative as well right away. Okay, so that would be your line, right? But if you just want to show from 0, then you can show that. So that's what it does. And that's my line, right? That's 4x plus 13. So we've done it correctly. So that's it. Just those two examples. Here's what I want you guys to work on. 12, 23 through 25, you could just put this next to the rest of your assignment. Again, all I have is, this is just 4 more problems. I'm not trying to give you so much work that you panic. I'm trying to help you end on a good note. Your test is not very lengthy. you're able to take it home. However, your study guide, I don't know if you guys noticed, but it kind of cuts off. That's because I had to cut off a lot of material. So I'm going to have to look at the test, but my guess is that the test is way too short if I cut off the material that I had from last year. So that would mean that I would need to add just a little bit, so I couldn't necessarily give it to you today. I would have to give it to you tomorrow morning. So let me see what I find out, but that's what you need to do, okay? And then Casey Gilbertson needs something from me. But you can do your quick little lap if you want.